Hello everyone and welcome to our third R tutorial for the network analysis course here at Insper. Today we will discuss a lot of concepts associated with the so-called Tidyverse. So this will be very useful not only for this course but probably for everything you might do in R. Okay? So Tidyverse is not a package actually, but a set of packages very useful for data science. The ones that you will probably encounter the most are ggplot2, which is very useful for plotting some cool graphs and for data visualization in general. Also the dplyr, which is useful for building and putting together new data sets and more general data manipulation. We also have the tidyr, which helps you organize your data in a format that is easily understandable. So basically we have lots of different packages here, okay? And in this website, so you can find more information about these different packages. You can, for example, click on ggplot2 and then you will get some more stuff here. You even have some nice cheat sheets here where you can find how the functions work for this ggplot or for the other packages as well. So this is a very useful website if you have some questions. So now let's open our studio and let's start to evaluate some of the properties, some of the different structures that these Tidyverse packages use, okay? The first thing that we are going to introduce today is what we call a table, okay? So a table is sort of a table, a data frame. It's very similar, but it's a different type of object, and it could be very useful in some types of situations because a table is actually a lighter type of object, so it also requires you to have your data formatted in a specific way, so your data needs to be a little bit more organized, and this could be useful for some types of analysis that you are going to perform, okay? So before we actually work with a table, okay, and you're going to see that it looks very similar to the tables that we are used to working with, okay, let's first load these Tidyverse packages into R. Okay, so first you need to install them, obviously. So you could type, for example, install packages Tidyverse. Okay, remember that Tidyverse is not a package, it's a set of packages, but you can install them as if they were just one package. Okay, I'm not going to run this line of code here because it could take a while, and I have already loaded this and downloaded these packages before, but this is what you should run in your console, and then you can load these packages by simply type library Tidyverse, okay, as you are probably used to by now, okay? Today we're going to use a data set called Iris, okay? So this is also one of those data sets that come with R, okay? So this is basically a data set with the measurement of some different variables for 50 flowers from each of 3 species of iris, okay? So you have here one species, which is Virginica, then you have the versicolor, and finally the setose species here. And here you have some different variables, okay? Let's play a little bit with this data set today, okay? So actually, if you have a look, you can see that the class of this object, okay? So this is a data frame, okay? And we are trying to transform this data frame into a table, okay? So what we have to do is simply typing as table iris, okay? And okay, it's with 2 sorry about that. So as table iris, okay, there you go. So you can see that it looks a little bit different, the structure here, okay, but the data is the same, so the organization is not changing that much. But since this structure has changed, this will be very different depending on the type of analysis we are going to perform. Okay, and you're going to see this in the R markdown for session 4, okay, where most of the functions are going to use these table objects. Okay, let's look at another data set. We have that empty cars data set, if you remember from our first R tutorial. So with the cars and then the miles per gallon and the cylinders and so on and so forth. This is also a data frame, so if you check the class of this object, you will see that this is a data frame, okay, which is actually the most usual type of table or of data object that you are going to find, okay? But if you want to have it as a table as before, all you have to do is type in as underline table and then empty cars, okay? And once again, you have this result here in this format, okay? So, so this is basically it. Well, you could also build your own table. So this is no big thing, as you could also build your own matrix in your own data frame. So for example, you could have a table where your first column, let's call it X, it goes from 1 to 5. Then your second column is full of ones, and then you want your third column, which I'm going to call Z, to be simply the sum of the two other columns. And then when you run this is what you get. So X is a vector from 1 to 5. Y, since you have just written 1 here, R considers that you want all elements to be equal to 1. And then finally Z is the sum of X plus Y. Okay, element by element. And then you get 2 up to 6. Okay, so this is what a table is. Okay, now let's introduce you to the second type of structure, the second type of operator that is going to be very, very useful for your analysis, okay? Which is what we call the pipe operator, okay? And it looks like this, okay? So, oops, sorry about that. So this is the pipe operator. So every time you see this, this is what we call a pipe in R, okay? So what is the idea about this pipe operator? We basically use this, okay, to simplify the functions, not the functions, but simplify our code. So what this pipe is going to do is that it is going to take what is on the left-hand side of this pipe operator as the first argument of the function that's on the left, on the right-hand side, sorry, of this operator, okay? Let me give you an example because I think it will make things clear for you, okay? So let's suppose I have this vector, let's call it x, okay, which is simply a vector going from 1 to 3, okay? So now you can see here that you have this vector defined, okay? Now I suppose that you want to sum, okay? So you could sum x, okay? We've done this before, okay? And then you get 6. Well, let's try to use this pipe operator. So what it usually says from the definition I mentioned before is that it could simply type x, then the pipe operator, and then sum. Why? Well, since this is on the left-hand side and this is on the right-hand side, so the pipe operator is going to take x as the first argument of this function. Okay, so basically it's going to perform sum of x. Okay, then you can run this line and you can see that you get the exactly same result that we had before, okay? Obviously, this is a very simple situation, so it's easier to simply type in sum of x, but you will see that for more complex types of operations, the pipe operator is very handy, okay? So let's work once again with our iris dataset. So let's leave it open, because I think we are going to use it quite a lot. So remember that if you type view with the capital V, then you open this data set here. Okay, the data frame is here now. Okay, so this is the data set that we are going to use. Okay, now as if you look here, you have all these different variables, right? But this is not really organized. If you look here at sepal length, there is no clear direction where this is going. So let's suppose that you want to have this in ascending order. Okay, you could use a function called the arrange function. Okay, so you could type arrange, then the data set that you want, and then the condition that you are going to use to arrange this data set, which is in this case would be the, let's say, the sepal length. Okay, so now you can look here, okay, and you can see from this preview of the data that this first column here is in ascending order. Okay, so you've changed your data set a little bit. Okay, but let's now show why the pipe operator could be useful. You could also have typed, for example, iris, then the pipe operator, then arrange. Okay, so I do not have to type in iris here because the pipe operator is going to take this iris here as the first argument of this function. So all I have to do here is type in sepal length. Okay, and then you can run this and you get the exactly same thing that you had before. Okay, so this is it. It's very important to know that if you go here to the iris data set, it continues to be in the original order. Okay, so when you use this pipe operator, you're not actually changing this iris object. Okay, you are just creating something else that is arranged in the way you want. Okay, so in order to have this iris or a new object with this order here, you have to assign this to a new object. Okay, or it could be the same object, but you have to perform the assignment again. Okay, so you'd have to do iris, I'll call this iris new. Okay, so let's assign this. Then this is going to be iris. Okay, let's use the pipe operator here. This is usually the structure that we have, so when you have a pipe, you move to another line. Okay, but that's not necessary, but this is what people always do. Okay, so arrange and then sepal length. Okay, so now let me run everything here. And now you can see that if you open this iris new here, then you have it in ascending order for sepal length. Okay, so this is why this is very useful. Okay, in case you're wondering, you can also use this in descending order. There's no problem about that. So just out of curiosity, we could have this iris new 2 data set would be the iris, okay, then the pipe operator arrange, but then let's use with the descending sort of function here, okay, and then sepal length. Okay, so let's run this here. Then if you go here to iris new 2, then you can see that it is decreasing in sepal length. Okay, this is another way to use this. But this pipe operator, so you can see now why it's sort of intuitive, right? But the more operations that you perform, the more useful it is. Okay, so let's create now a third object called iris new 3. Okay, which is going to be the original iris object. Okay, then let's work with another function just so you know more functions. Okay, let's use the so-called mutate function. Okay, this mutate function is going to create a new variable in the original data set. So let's suppose that I want a data set called sepal length 10, which will be sepal length times 10. Okay, so this is very naive, just for us to practice a little bit. Okay, and then let's suppose that I want to filter. Okay, this is another function. I just want to filter those observations with sepal length 10 larger than, let's say, 50. Okay, so let's run. And then there was a problem here. Oh yeah, there was a mistake here. I missed a G here. Sorry about that. So now let's run everything here. Okay, and then you get this iris new 3 here. Okay, and then if you open this iris new 3 here, you only get objects, the observation, sorry, with sepal length higher than 50. Okay, actually you should look at this new variable that we have here, which is just 10 times larger than this one here. Okay, there are lots, all this arrange function, mutate, filter, those are all tidyverse functions. Okay, and I'm going to post you guys some PDFs with all of these functions and how you can use them. Okay, which is because they are very useful, but you have to practice a little bit until you know which functions you should use. Okay, another function, just because I think this is important, is the select function. So let me create this object called iris select, and then this is iris. Let's use the pipe operator here. Okay, and then select sepal length. Let's not make this wrong again. So yes. So now what I'm going to do here, I'm selecting only this one column. So if I go to iris select here, I only have this one column, only this one variable, because this is the only variable I have selected. Okay, so these are some important functions. Okay, but there are lots and lots of them that you might use here. Okay. Okay, so now let's introduce you to a final concept today, and this is also very useful, which is the join functions. Okay, there are many different functions you can use to join two data sets in R. So you have the left join, the right join, the inner join, anyway, the full join, where you have all these different functions. So, but today let's focus on, just for you to know, kind of have an idea of how it works. Let's work with the left join function, okay? Because I think this is one of the probably the most intuitive one, okay, and the one that you are going to use the most, okay? So first, let's construct two data frames, okay? Because I think this is easier if you work with a very simple one. Then you can clearly see what's going on here. So let's create an object called names, okay? And I'm going to call this the names. Let's work with 3 people only. So this will be, I don't know, Pedro, Thiago, and then the third guy could be João. Okay, so let's make this very simple. Okay, so I have created his names. Okay, they'll have an age associated with them. So they will be 20, 21, and 22 years old. Okay, and then let's bind them in this matrix 1. So let's column bind this. Okay, this will be the names and then age. Okay, but this is a matrix and I don't want a matrix. I want a data frame. Okay, because data frames are easier to work with and they are lighter objects as well. So let's work with matrix 1. So this will be as data frame, the matrix 1 itself. Okay, so now if you check the class of matrix 1, this is what you get. So this is a data frame. Okay, now let's create another object, okay, another matrix or another data frame with another information about these people. But let's introduce a new guy here. Okay, so instead of having those names, let's have names 2. So let me copy this here. So I'll work with the same guys here. Okay, but I'll put another guy here in the middle. Okay, so this new guy here will be, let's say, Henrique. Okay, so see what's wrong here. Okay, there are 2. I just need 1. Okay, so that's fine. Okay, so these are the names 2 vector. Okay, let's also create another characteristic. So siblings, how many siblings they have. Okay, let's keep it very simple, very naive. Let's work with 1, 2, 3, 4. Okay, and now let's create a matrix 2 by binding these 2 column vectors together. Okay, so I'll bind names 2 and siblings. Okay, and then let's transform this matrix 2 in a data frame. Okay. That's data frame. matrix 2. So there you go. You can also check the class if you want of matrix 2, and that's a data frame, okay, as we were expecting. Okay, so now I want to have just one data frame with the name of the original three guys, their age, and the number of siblings that they have. Okay, so what I could do here is that I could use this left join. Okay, so let's suppose that I want to keep the first function, the first matrix, as the original, as the baseline matrix, so to say. Okay, so let's create, so C matrix 1, then let's use the pipe operator. Okay, then I'm going to use this left join function. Okay, so what this left join function is going to do, so it's going to take all elements from the left function, from the left matrix, which in our case here is matrix 1, and it's going to join with the information from the right hand side matrix, which in our case here is matrix 2. Okay, and then I need to tell R what is the condition that it is going to use to bind, to connect the data in these two data frames. Okay, so I'm going to join these two matrices by the name. Okay, but the thing is that the name is different. The name of the column is different in the two data frames. So this is going to be joined by the condition that the names in the first matrix is equal to the names in the second matrix. Okay, now let's run this, and then let's see what we get when we type matrix 1. See, so now we get this. This is a very simple case, but again, name of the students or of the guys, their age, and the number of siblings that they have. Okay, you can see that there is no Henrique here because Henrique was not on the left hand side, was not on the left data frame, and this left join does the following. So it takes all elements from the left matrix, which in our case is matrix 1, and tries to find the information that matrix 2 has about the elements in the original matrix. Okay, and then this is what we get. Okay, so as we mentioned, there are many different functions. Okay, I would argue that this tidyverse thing is one of the best parts about R. Okay, but you actually need to practice it, and so this is something that you will start to get used to when you start using R more and more. Okay, but I hope that especially with this pipe operator here, okay, that at least you got an idea of how it works. So this is very important, right? So remember that when you have this pipe operator, what it basically is doing that it is taking the element, the object that is on the left hand side and using it as the first argument for the function on the right hand side. Okay, so that was it for today, and I hope you've enjoyed it. And if you have any questions or any difficulties, please just let me know. Thank you, and bye.